Hello guys, I'm Shayo Enoch. Welcome to my maths tutorial class on circle theorem. In this tutorial, I'll be taking a look at GCSE, IGCSE, IB, PSAT, and AISL exam style question. So let's take a look at the first question. In the diagram, BCD and E lies on the circle center O. AB and AD are tangent to the circle. Angle BAD is 48 degrees. Find angle ABD. Okay, so guys, I told a bad angle, guys. This is a bad angle, 48 degrees. So BAD is 48 degrees, so we have to find ABD. So let me just work with that. Let me work with this. So ABD, now this is A, point A down to B and D. So this is ABD. So and the angle there is angle B. ABD. So that is the middle angle B, this laser angle here. So we have to find this laser angle there. So guys, let me just complete this diagram. So now if you look at this, we have angle triangle ABD. So this is a triangle where angle B and D are base angle is this isosceles triangle. So isosceles base. So it's such that this angle here, let me use laser. So angle B and angle D are equal. That is base angle of isosceles triangle. Okay, because this is a tangent AD and AB. So this length here AD, let me just use straight line there. So this side AD is equals to side AB, such that angle B is equals to angle D, isosceles base. So now if you consider this triangle, if you consider triangle in triangle AB, ABD, the sum of angle in the triangle is 180 degrees, and two of the angles are equal. So let's start the two equal angle XX. So what I'm going to do now is sum the angles and then plus 48, that should give me 180, such that in this triangle ABC, 2x plus 48 should sum up to 180 degree. That is, the rule is angle sum in a triangle. Angle sum in a triangle is 180 degree. So then from there I can go for my x now. So 2x will give me 180 minus 48. Okay, I'm not sure I'll be wasting much time writing everything like this next time. Okay, just let's start like this. 132. So then so x will be 132 divided by 2. So that is what let me use my calculator here, divided by 2, and that is 66 degrees. So guys, hope everything is clear now. So this angle here, meaning that this is 66 degrees. Okay, so angle OBD, I can't clear the screen, guys. I don't know, let me just do that. So this is clear, so I don't need that part again, so we are through with that. So let me just erase this. So 66 degrees, so I can use that space to solve the remaining question, guys. So this should be my work area. Okay, angle OBD. So to find angle OBD, that is OBD. So this angle B here. So guys, let me just use can I go with laser again? Yeah, okay. So now look at this now. Since this is a tangent, let me just work with this. I want to extend this AB. This AB down here. This is a tangent here. Okay. And don't forget that tangent to radius is 90 degrees. So when you have tangent to radius and this radius, these are radius, this OB and OD are radius. Okay. So when you have tangent to radius is 90 degrees. So let me go with that now. So tangent to radius is 90 degrees. So from here, this is radius down to the tangent is 90 degrees. Okay. So meaning that the entire angle here, meaning the angle ABO is 90 degrees, and we have angle ABD to be 66 degrees. So now to get OBD, you just take away, ABO from AOB. So that's how to get this. So I think I can go with that now. So to find this one now, angle OBD, angle O. Am I writing like this, guys? Okay, don't do that for me, guys. Okay. That's not funny, and I'm not impressed with that, guys. Huh? So this boss sometimes misbehave. And I clean this trash here. Okay, so let me go ahead with that. Sorry about that. So I want to go angle O B D equals what? Angle A B O minus angle A B D. Now don't forget that ABO is tangent to radius, and that is 90 degrees. So that will be 90 minus, and we have from question 1 ABD, that is 66. So 90 minus 66 will give us what now? So 90 minus 66, that gives me 24 degrees. That's super good, right? So this place is 24 degrees. I don't know if I should wipe this. I think I'll still need that page. So let me just, I don't need the solution again. So let me just take it off. Okay, so what else do we have there? We have to find angle BCD. Okay, angle BCD. Okay, so can I change the color of this pen now? I don't want to waste my time, guys. Let me just continue with let me just work with laser. Yeah. So BCD, this is B C. Okay, I should use line. I can't just use laser like that. Okay, let me go for line. Not geometry line, guys. Okay, let me just use this just to show you something. So this is BCD. Okay, so BCD. So this here, BCD. So I'm looking for angle C. I'm looking for angle C. So this angle I'm looking for here, this angle C, I'm looking for this angle here. Okay, guys, don't forget that this is radius, yeah, and BOD is isosceles triangle, so that OB and OD are radius. So let me just use something to indicate that, meaning that these two sides are equal. This angle OD and OB are equal. So we have another isosceles base here, guys. And don't forget, this is 24. This angle OBD is 24. This is 24. Definitely this is 24 now. So I can have angle sum in a triangle now. Do you want me to write that, guys? Let me just do that. So this angle D here, if I take ODB, something like that, and this OBE here, this angle here too, the isosceles base, they are equal. And this is 24, so this other, so the remaining two will be 24. So this will be 24 degree, and this is also 24 degree. Okay, then I have angle sum in a triangle 180, so I can get to this place. Let's tag this place Y. So let's go for Y now. So Y plus 24 plus 24 equals to 180. That is angle sum in a triangle 180. And then what triangle am I referring to here? This triangle is triangle BOD. So let me just put it there in triangle BOD. Okay, so in triangle BOD, then we have this. So then Y will give me 180 minus 48. Okay, from there then my Y will be what? So what is 180 minus 48? 180 minus 48, that gives me 132. So this angle Y here, let me just use arrow to indicate that now. This angle Y here, this angle here, this here is 132 degree. 132 degree. Okay, now I can now go for BCD now. BCD. Now, angle subtend at the circumference is half angle at the center. Or better still, angle at the center is twice angle at the circumference. So I'm looking for this place now. So this is Y over 2. That's the implication. Because it's half angle at the center. And angle at the center is BOD. And I've gotten my BOD, and my BOD is 132. I'm looking for BCD. So BCD will be half of this. So half of 132 now will give me BCD. So angle BCD now. Angle BCD now. So BCD will be half of 132. So 132 divided by 2. Guys, I will not be careful to write the reason. The angle at the center equals to angle at the circumference is half angle at the center. So don't let me just write that. So just take that like that, divide by 2. So that will be 66 degree. So that's quite interesting. So this place is 66 degree now. 66 degree. Oh, why am I writing degree like that, guys? Like 660, guys. Okay. So the last question now. What angle bed? Guys, bed. I'm feeling sleepy, guys. Why bed? Why not pillow, guys? So let's go for angle bed, guys. BED. So this is BED here. I'm looking for this angle. Let me just use laser. So I'm looking for this angle here. So if I think I would have loved to change this color, but no time for that. Let me just work with texture pen now and line. So now I'm going to consider, let me just look at this arrow now. So look at this quadrilateral, B to E, from E to D, and from D to C, then from C back to B. So this is a quadrilateral, don't forget. So when you have a quadrilateral inscribed in a circle, so that is cyclic quadrilateral. Okay. So and the opposite angle of cyclic quadrilateral are supplementary. Meaning that if I add angle BCD and BED, then it should sum up to 180. Supplementary means that they sum up to 180. So angle bed now, that is angle E plus BCD, should sum up to 180. And I have this to be 66. So the implication of that is 66 plus angle bed or angle E. Let me just tag this one angle E. Okay, equals to 180 degree. The reason is opposite angle of cyclic quadrilateral supplementary. So definitely, so angle E there will now be 180 minus 66. This 66, not 60, guys. So 180 minus 66, that is 114. So this is 114 degree. So and that's the end of the first question. Let's go for another question. This is 144. So guys, I hope everything is clear. So cycle theorem is quite interesting and a very good one too. So just clear the page now. So let me import another question. Okay, let's take a look at C2. Okay, this is quite interesting. This is not funny, guys. Can I just make it a little bit bigger? Let's just try that. I think it's cool like this. Okay, guys, so this is what we have here. ABCD is a cyclic quadrilateral. The tangent at C and D meet at E. So calculate the value of PQR. So we have to calculate the lateral value PQR. So how do we start, guys? So let me go home. Let me go for my lines. Okay, now if you look at this, guys, so the first thing here is EC is a tangent and ED is also a tangent. But here I don't have radius, guys. I don't have radius, so I'm not going to really work. So I don't have something like tangent to the circle is 90 degrees. So I can't be that smart, guys. So guys, the first thing is to go for angle P, and that's the first question. Very easy, guys. So if you look at AD, then DC and line CB and BA, that is a quadrilateral. So it's not just a quadrilateral, it's a cyclic quadrilateral, guys. So this rule is only applicable when you have a quadrilateral inscribed inside a circle. It's not general, it's not conventional quadrilateral. There's no rule that states that sum of opposite angle of quadrilateral is 180. It is sum of opposite angle of cyclic. So the quadrilateral must be inscribed inside a circle. It's a cyclic quadrilateral. So you see that P and 126 are opposite angle of a cyclic quadrilateral now. So then I can finish up this now very fast. So I have angle P plus angle B, and let me just say 126 because I have the value for angle B already, equals to 180. And the reason is opposite angle of cyclic quadrilateral sum up to 180, or better still are supplementary. So angle P will just give me 180 minus 126. So 180 minus 126. So that is 54. So this answer here is 54. This here is 54, guys. 54 degree. So that was good, 54 degree. I think I can manage the space. I don't need to clear the body. Okay, so let's go to the next question. Let me just demarcate that. So I'm through with this. Okay, next angle Q. This is Q here. So just take let me work with laser now. So if you look at angle P here and angle Q here, and this 75 lies on line DE, so which is a straight line. So angle sum on a straight line is 180 degree. So the implication of that is by P plus Q plus 75 sum up to 180 degree. So that angle on a straight line. Okay, so not going to waste much time here. I'll just go for my Q now. So Q will give me what? 180 minus 75 plus. Okay, so now we have Q we have P here already to be 54. So 54. Guys, hope you understand what I'm trying to do here. Better still, you can just add them 75, 54 plus 75, the answer, then take it away from 180 degree. So that's what I'm trying to do here. So Q will now give me, I think that I manage my board well, guys. 54 plus 75. 54 plus 75, that gives me 129. So 180 minus 129 and gives 51 degrees. So Q is 51 degrees. So the answer here is 51 degrees. Okay, finally, looking for angle R now. This angle R. Okay, guys, there's no trouble again, guys. We can just go with tangent. Now this line here, CE, is a tangent, and this ED2 is a tangent, such that this side equals to this side. Isosceles base, okay, are equal. So maybe the angle Q equals to angle C here, but I'm looking for angle R. So, and I have angle Q to be 51, so I can tag this place here. I can tag here, this is 51 based on what I have here, and this place also be 51. Angle C is 51. Okay, so let me just write 51 there. So I can now finish up now. So I can have angle sum in a triangle. In triangle DEC, the sum of the angle sum is 180. So 51 plus R should give me 180. So R plus 51 plus 51, that is 51 times 2, and that is 102. So R plus 102 should sum up to 180, and the reason is angle sum in a triangle. Okay, so that's it. So then R will be 180 minus 180 minus 102, and that is 78 degree. So R is 78 degree. So this place is 78 degree. Okay, guys, that's super cool. Let me just clear the page and go for the next question. I don't know, can I solve like 2 or 3 more questions? Can we could go for difficult one? Is there anything like difficult one, guys? Let me just go for question 3. I'm not sure I'll be able to solve everything, but let's see how we have time on our side and we try and solve everything, guys. I think I would love to solve everything. Okay, so here I have AOB is a straight line. B and C are point on the circumference of a circle, center O. Okay, then AC is a tangent to the circle, and work out the size of Y. So want to work out the size of Y, guys? It's like work out the size of Y. Why must we work out the size Y? Why? That's letter Y, guys. Okay, now so if you look at this triangle COB, this isosceles triangle, because OC and OB are radius, guys. Oh, is it a radius or radii? Yeah, radii. So one is radius, and guys, mathematics terms, cards, not easy. Okay, so why am I clicking this guys? So OBD is a radius, and this is a radius. So then the implication is that this triangle is a isosceles triangle, and I mean isosceles triangle base angles are equal. So this angle here will be equal to this angle here. So I have Y here, so I don't need to waste my time, guys. Okay. Then next, guys, what's going on here? So next, I'm looking for angle Y. So, and I have this 46. So now, guys, what's the next stuff here? Now, since this is a radius, tangent to radius is 90 degree. Tangent, this is a tangent. Okay, tangent to radius is 90 degree. Don't forget, tangent to radius is 90 degree. So this side, guys, come here. So this is 90 degree. Okay. So what else can I infer here, guys? What else? What, this question look quite difficult, right? No. So guys, let me quickly give you this rule. Now, if you have a triangle, here. Let me target triangle. Cats, don't distract me here. So let me target triangle A, BC. Okay, ABC. So I have angle A here and angle B here. So the exterior angle here equal to the sum of the two opposite interior angle. Meaning that this exterior angle here will be A plus B. I should have used lowercase, but not bad, guys. So exterior angle. So exterior angle is equal to sum of the two opposite interior angle. That's what I want to do here now. So this exterior angle here will be sum of the two opposite interior angles. So this place is 2y. This place is 2y, guys. This place is 2y. Then I can finish up this stuff now. So then I can now consider this triangle now. So consider triangle OC. Okay. Then C to A, then A to O. So in triangle AOC, and the sum of the triangle is 180 degree because angle sum in a triangle. So what are the angles I have there? I have 46 plus 2y, then plus 90 degree. Should give me what? 180 degree. Yeah, 180 degree. So then just go ahead and let's finish up now. So 2y will give me, what is 46 plus 90? 46 plus 90, that gives me 136. That is 136. So 2y will give me 180 minus 136. 180 minus 136. Okay, so from there I have 2y. So 2y equals to, guys, let me just use the calculator I have here. Okay, let me just go ahead. Okay, 180 minus 136. So that's 44, guys. So if this is 44, my handwriting is quite cool, right? So then y will be 22 degree. So guys, I think you enjoyed that. That's a cool one. So y is 22 degrees. So angle y is 22 degrees. So I can clear the board now. That's all we have to find, guys. So we don't need to waste our time. Clear the page. So insert next question. Can I just go for this, or should I just jump to something like question 8? Let me solve 2 more. So I'm going to take random question. So let me just go with question 4. Then I'll take probably 6 and 8 or 5 and 7, something like that. Just look at it. Okay, do we have something like this before? No, I think this is something quite new, so we can work with this. So let me make it a little bit bigger, guys. I want to make it a little bit bigger. So cool. Can I bring this thing down small? Okay, guys. So RS is a tangent to the circle at R. Calculate the value of X, giving reason for your answer, guys. I'm going to discuss the reason. I'm not going to write it, guys, because of our time. Okay, so go home now. So what are we have to find X. This is what we are looking for here. X, guys. X, guys. Okay, so this game over. There's no radius here, so you don't even take a look. Don't think about radius, guy. Now, so I can't talk about 90 degree here. So now look at this triangle. So this is another rule, guys. I need to use line. Line. So go ahead. So now consider this triangle RQP down here. So triangle RQP. Why am I saying like RPQ, something like that? RQP. So you consider triangle RQP. If you look at this triangle now, when you have a tangent, anytime you have a tangent, do you understand? And you have let me go for my add pen now. Tangent to a chord. A tangent to chord is different from tangent to radius. You know, tangent to radius, don't forget tangent to radius is 90 degree. But this is a tangent to chord now. So a tangent to chord, the rule we have there is what we call alternate segments. alternate segments. So if you look at this chord now, this line, so this chord form make angle with line RQ. So it's not going to be equal to any of this, so it will be equal to this one. So angle RPQ equals to QRS. So we call it alternate segment. So the implication is that this place will be 42 degree, and the rule is alternate segments. This is 42 degree. So when you have a triangle in a circle, so a triangle is scribed inside a circle. Okay, the way we have cyclic quadrilateral, can we call this one cyclic triangle? So if you don't mind, so 42 degrees. So that's how I come about that. So game over already. So I can now angle sum in a triangle now. So angle sum in a triangle, 42 plus 55 plus x. Don't forget that rule is alternate segment, guys. I'm not going to say they ask us to give reason for our answer. So alternate segment. Then the second rule is angle sum in a triangle equals to 180 degree. So x will give me 180 minus the sum of those two guys there. So 42 plus 55, 42 plus 55 is 97. So minus 97. So x equals to, so 180 minus 97 is 83. So x equals to 83 degree. Do I need to write it here, guys? I don't need to write it here, but I'm writing it already. So clear the page and let's go for the next question. I think I will try to solve all the questions, guys. I'll just try to be a little bit fast. Maybe a little bit faster, guys. Provided my board will not misbehave. Question 5. Okay, so take this one here. Let me make it a little bit bigger. A little bit bigger, guys. Okay, AC and BC are tangent to the circle with center O. And find this side, guys. So this is not funny, guys. This is not funny, guys. Okay, so guys, just take a look at this. Don't forget that this radius, line OB is radius, and OA is radius. Okay, then I have this line AC is a tangent. We understand from the previous question we solved earlier that tangent to radius is what? 90 degree. So this is 90 degree. So tangent to radius is 90 degree. Then I can finish up now because I have my quadrilateral now. So what is the quadrilateral? ACB ACB guy ACBOA is a quadrilateral. Okay, and the sum there. What am I talking about? Why am I like this, guys? Yes. So this is side 1, 2, 3, 4. So should sum up to 180, guys. What? 180? How can that be possible? This local guy didn't know what he's talking about. It should sum up to 360 because we have two triangle in a quadrilateral, and each triangle is 180 degrees, so it's 360. So and that should sum up 360. But I don't need this demarcation, but it's pretty cool. But let me remove it because I don't want it there. So then I should have what here now? So 90 plus 90 plus 4x plus x sum up to 360. Okay, so 90 plus 90 is 180. So the implication is that 4x plus 4x is 5x. 360 minus 180. I'm writing 5x, guys. 360 minus 180, that will give me 180. So 5x equals to 180. So then x will be 180 divided by 5. So what is that, guys? 180 divided by 5 is what? 36. That is 36. 36 is like 36. So x is 36. Okay, guys. Clear the page, guys. So it starts a new question. I think I'll just solve one more. Let me solve two more. So after this one, then I'll go for the last one. And the implication is that virtually, I think I end up solving everything because question 6 and 8 are the same. So I'm going to end up solving everything. What? Why can't I solve this one last? This look quite difficult for me. I'm afraid of solving this question, guys. Okay, so let's take a look at this. I don't know why they're having parallel. Why are they giving us parallel side in cyclic in circle theorem? Okay, so I don't know. So guys, let's just get started. Okay, shown is a circle, center O, B, C, and D are points on the circumference. ABO is a straight line. AC is a tangent to the circle. Work out angle AOC. So AOC, AOC, AOC. So guys, let's go for AOC. So did I need to waste my time with these guys? Nope. Nope. I'm not gonna waste my time with these guys. So this is CA. CA is a tangent, and OC is radius. And I know that tangent to radius is 90 degree. Then consider this triangle CAOCA or OAC. So anything, guys. Then I can go for this side here, side O here, and that is BOC. So that's BOC. So, and I'm going, how do I solve this one? I'm going to solve in a triangle is 180. This is 90, so take away 90 from 180, so, and that's remaining 90. So let me just tag this laser X. So the implication, let me just write everything, guys. No, I'm not going to write everything. X plus 32, let me write everything, guys. X plus 32 plus 90 equals to 180, and that the reason is angle sum in a triangle is 180 degree. So X will give me that is 180 minus 180 minus 122. Hope I'm correct, because sometimes I do have problem with addition of numbers, guys. 90 plus 32. Yeah, correct. So 180 minus answer is what? 58 degree. So X is 58 degree. So that is angle AOC. What? Why did I write my 58 like that? Guys, that is not funny. 58 degree. What? Okay, so work out BDC. BDC. So I need this angle here, BDC. Oh my, oh my, this look quite difficult. Okay, so BCD, this is B. Let me just use straight line there so that I can this one. Let me go with this. So B DC, B DC. So I'm looking for this angle here, this laser angle here, angle D here, this laser angle here. Guys, if you look at this laser angle here, it's not funny. Why are they giving us laser angle there, guys? Guys, don't forget I got my X here, and this X is angle at the center. Guys, this is angle at the center. Let me just make this point. I don't need to put this there, but I just want to do that. Let me just put this one. Let me join B to C so that you understand what I'm trying to do. Now B to C is a chord, and you have a chord bounded by an arc. So what you have there is a segment. So this is a minor segment now. So everything, all angles subtend up there will be the same. Angle subtend at the major segment. So I can subtend any angle at any point on the circumference, just like this angle D. So this angle here is half angle at the center. Angle D here is half angle at the center. Okay, guys. So let me tag that place Y. Because any angle subtend at the circumference above on the circumference here, any angle subtend here at any point here will be the same, will be equal. I can go ahead and extend this, guys. I can draw as many, I can subtend as many angles as possible. I can do this. I can subtend as many angles as possible. I can go ahead and do this, but that's not part of it. So all these angles, I'm going to subtend they will be equal. So the implication is that everything there will be y, as in why are we solving? Why mathematics? Why circle theorem? Why can't we do something else? Why must we make life difficult for ourselves? Why? So all this why, guys, all this why, all this why will be equal. And the angle subtend are the circumference and the half angle at the center. X is center here. So my x will be half of 58. 58 over 2. Why would they say my x? This y, guys, this letter y. So my y is x over 2. That is 58 over 2. So what's that? 58 divided by 2 is 29 degree. So this is 29 degree. So the implication is that angle BDC is 29. Finally, ACD. ACD. Oh my God, this is not funny. ACD. What? ACD. God. Okay, so let's go with that. Let me just work with this so I can clear this broken line. ACD. This angle here. ACD. Okay, guys, ACD now, that's that. So how do we go about that, guys? You should know that we should be able to get the answer from the last solution here. We have y here already, guys. We have y. So why can't we work with y, guys? So, guys, I don't know where that noise is coming from. I just need to quickly do this, guys. Okay, guys, just need to check something. Okay, so now if you look at this the information, we have this information that AC is parallel to BD. So let me just extend this the parallel lines now. Let me just extend this. Let's have the extension. Let me just go with this arrow. So this parallel. So I want to extend line AC down here like this. Just extend it. Okay. So now, don't forget that when you have don't start that, guys. Can you drop this thing? Thank you. My boss sometimes misbehave. Okay, so I want to extend this. It's okay, just drop it there, guys. Okay, so guys, let me just quickly, just a quick one. So if you have two parallel line and you have two parallel line cut by a transversal, then you end up with what we call alternate angle. I call it Z angle, Z, this one. So this angle here equals to this angle here. So let's say if this is what to be N, then this place will be N. So Z angle, Z angle. Okay, so you can see the Z here now. So this Z, let me just use this line to show you guys. So let me just take here now. So from BD, so let me just take it from here. So this is my Z angle. This is Z, letter Z, letter Z, letter Z. This is Z angle, Z. So the implication is that this place here will be Y. So let me use laser there. This place here will be Y. And that is 29 also. Also Y is 29. So this angle here too will be 29. So 29. Okay, guys, I'm actually looking for ACD. Okay, ACD. So ACD now, ACD. So I just need this small part here. If I can I use light pen, brush? Let's go for laser, so at least I can indicate it. So this one here, what I'm looking for is because I know that this place down here is 90, and this is a radius. So from here down here, that's what I'm looking for. So I'll just add this small portion to 90. This blinking portion, this laser portion to 90. So that will give me ACD. Okay. So now, let me now work with this again now. So don't forget that blinking, that portion there. So now don't forget that this is a tangent. This is a tangent. Tangent to radius is 90. That is this radius. This OC is a radius. So let me take it from here. This I want a line, guys. Okay. So this is a radius. This radius here, when you bring it down to the tangent is 90 degree. Okay, so from 90 take away 29, then you get y, because everything here is 90. So I can divide 90 into 29 plus y. This small part is y, and the remaining part of 90 is 29. So so if I want to get this small portion here, this letter y here, I don't know, have I used y before? Okay, so don't let me use letter y again. Let me just use something like letter p. Okay, laser. So let me change this y to p. So I'm looking for this letter p here, and letter p is just from here down here. Do you know this is 90? Line OC down to the tangent is 90. From 90, I have 29 out. So I can have the remaining P. This is blinking P. So P there. So P will just be 90 minus 29. 90 minus 29. So then that letter P there will now be, I'm not write it like that, guys. Just take it like that, guys. So 90 minus 29. So that's 61. So P is 61 degree. So the implication that this remaining portion here, this portion here, and let me just use arrow to indicate it. This remaining portion here, this angle here is 61 degree. Can use add pen now. This is 61 degree. And what am I looking for? I'm looking for ACD. ACD. So ACD, because from here now, so what I'm looking for is from down here and end here. So I'm going to add 90 because tangent to radius is 90, then plus P. So that will give me this. So this answer will now be 90 plus P. So 90 degree. My body is misbehaving already, guys. 90 plus 61 degree. And that should give me what? Plus 90. So the answer is 151. So guys, I hope that is interesting. So ACD is 151. So let me clear my board for the last question. Insert image, guys. So guys, just watch this last question. So this is not going to be as demanding as the very first one. Look at this question here. This question C6 and C8, they are the same. I solved 7, so definitely C6 will be a little bit, I wouldn't know, it could be more demanding. I care a little about that, guys. I just care a little about that, guys. Guys, I feel like playing Naruto Ninja Storm game. I'm tired of solving math, guys. I want to go ahead and play video games, guys. Okay, so what is this question all about? A, B, and C are points on the circumference of a circle with center O. AOB is the diameter of the center, and CD and BD are tangent to the circle. Angle CDO is 29, and work out the size of AOC. So we have to work out the size of AOC, guys. Now let's see, AOC, this guy, yeah, that laser. So we have to find out AOC. Oh my gosh. Okay, so how do we go about this? To solve this problem, this is center O to circumference, that is radius, and this center O to circumference, this another radius. Okay, and line A to B is a tangent. Okay, I know that tangent to radius is 90 degree, so this guy here is 90 degree. So the same reason here, this guy here too is 90 degree. Okay, so what else can we do, guys? Okay, so what else can we do now, guys? If you look at this, just let's go for COD. That's a complete triangle, and you have 90 and 29 out. So this remaining part here, this guy here, let me just take it like that. It's not 90, this is not perpendicular, it's just like, I just want to do this. So this guy here now will be so let's just label, let's tag that guy there P. That is in triangle COD. So I'm working with triangle COD now. So angle P plus 29 plus 90 degree. My board is going to misbehave, I know. So let me just quickly pause the video so that I can continue from there. Pause. Okay guys, sorry about that, my border misbehave. Okay, so um as I was explaining before now, this is a tangent and this is radius. So tangent to radius is 90 degree, and this also tangent to radius is 90 degree. So if you consider in triangle, um in triangle COD, like chord guys. So in triangle COD, that is COD, the angle sum in a triangle is 180 degree. So let's just tag this place N. Okay, so we have why they say in chord, it's in chord guys, just in triangle COD. So in triangle COD, then I have the angle sum there should be 180 degree. So 90 plus 29 plus N should sum up to 180 degree. So from there N will just give me N should give us what, 180 minus the sum of these two guys there. So 90 plus 29, that is 119. So 180 minus 119. So let me just write the answer here guys. 180 minus 119, so that's 61. So N is 61. So this N here is 61, and I just write equals to 61 here. Okay, the same reason there, because this is a tangent, and mean implication that these two sides are the same, equal, and this radius to this are also equal. So the implication is that here this place 2 will be, I need to waste my time with this place will be 29. Yeah, so you don't need to waste your time with this 29 degree. Okay, no, my handwriting is not cool. So let's just go for the this is what we asked to find, AOC. So let's put this laser guys, and let's put letter K there. So we are looking for letter K. Okay, so since this place is 61N, so this place also here will be 61, because this is 29. So angle sum in a triangle should be 180. So the implication, this is N, so this is 61. So then I can now work with angle sum on a straight line. So K plus 61 plus 61 lies on a straight line. So that's angle sum on a straight line is 180 degree. So then K would be 61 plus 61, and that is 122. So 180 minus 122. I don't know why I continue using laser guys. Okay, so and finally we are getting to the end of our tutorial class section. 180 minus, let me just do minus, I just like to play guys. I'm super playful. So that is 58 degree. Guys, sometimes it's cool to play with maths, right? 58 degree. So guys, this is the end of our tutorial class on circuit theorem. I hope you enjoy the section. And guys, to get more worksheet on circuit theorem, and maybe on more worksheet on IGCSE, GCSE, PSAT, AISL exam style question, and just go ahead and log into this site here. Okay, or just copy this and just copy and paste on Google. And also please do well to subscribe to my channel for ICT and mathematics and video. So guys, have a great day ahead. Bye bye guys. Bye guys. I just go and play Tekken. Nope, I prefer to play Naruto Ninja Storm. Bye guys.